Hello everyone, my name is Hemu and today's we are here for the Palo Alto Firewall Day 2 class, and in today's class we will entirely discussing the packet flow in your Palo Alto Firewall. So generally let me tell you how people used to ask this particular question in the interview. They will ask can you explain the packet flow of Palo Alto Firewall? Maybe they will ask, can you explain the life of a packet inside the Palo Alto firewall? Okay, so they will ask this question in these two type of ways. Okay, and if time permits, I will basically try to cover the initial access. Once these two topics will be completed, and guys, after that, you have a time of 5 days. Okay, on these 5 days, just revisit these two recording like your day one recording and day two recording two times at least, so you will grab all the things. And even though if you will able to answer these two questions in the interview properly, you can able to crack. Okay, because here we have discussed so many things. Okay, cool. So let me go here. So guys, if you will see in this diagram, I have one PC. This PC is a part of my inside zone, and this PC is behind Ethernet 1x2 interface. And that PC have IP address 10.1.1.70. This is my internal PC. I have my Palo Alto firewall, and Palo Alto firewall Ethernet 1x1 interface, which is a part of outside zone. And in outside, basically, let's say we have a server somewhere over the internet. Okay, and let's suppose that server have some IP address. So let me just take one hypothetical IP address. Let's suppose this server have IP address which is 151.7.1, and that server is running the web services on TCP port 443. Okay, this is the setup right now we will be having. So guys, as I also discussed yesterday, let's suppose this PC wants to start the communication with this particular server. So when it will start the communication with this particular server, the very first packet which is initiated by this PC is your TCP SYN. Right now, TCP SYN received by the firewall. Firewall do the processing of TCP SYN, and after that, he will basically forward this particular request over this server. That's true, right? Now, if we want to see how this particular firewall is doing the processing for TCP SYN, let's try to understand that part. So as I have mentioned in your yesterday session as well, Palo Alto Firewall have a packet processing stages, and every packet needs to go through with these stages, right? So guys, and these are the things which you need to remember. So I'm just putting here TCP SYN packet processing. How this packet gets processed by the firewall? Now when firewall receive this packet, what it will do? It will send this packet through the ingress state. Ingress stage. Then this packet go towards the flow lookup. And after that, silo path, which is a session setup state. Then it will go towards the fast path. This fast path is also known as layer 2 to layer 4 processing. Then the fifth one, this packet go towards the forwarding stage. This is how the TCP SYN packet processing done by this particular firewall, which is Palo Alto Firewall. Now this SYN request reach till this server. Now this server will give the reply. And when he will give the reply, he will send the second packet, which is TCP SYN plus ACK. Now this TCP SYN plus X received by the firewall, and what firewall will do? Firewall will start the processing of TCP SYN plus X. Let's try to understand how the packet is processed by the, how this TCP SYN plus X packet, which is a second packet in your TCP three-way handshake communication, how my firewall going to process. Packet processing. And guys, these processing you need to remember, okay? Then only you can able to troubleshoot the issues. So the very first packet, this first packet when received by the firewall on Ethernet 1x1 interface, what it will do? It will put this packet into the ingress stage. Then your flow lookup. Guys, is this time my firewall, when it will do the flow lookup into the flow table or into the session table, this time it will found the session detail, right? And if firewall, what firewall used to do when it will found the session detail? It will bypass the silo path, right? Why it is bypassing the silo path? Because my firewall, this firewall is a stateful device, right? It is a stateful device. So your packet directly go into the first path. And after that, your packet go into the forwarding stage. And finally, this packet reached here. Now this PC will send next packet, which is a third one. In TCP three-way handshake, third packet is just acknowledgement, right? ACK. Now, when this acknowledgement packet received by the firewall, what firewall will do? Firewall will start processing the third packet, TCP packet processing. So what it will do? It will do the ingress stage processing. Then it will do the flow lookup. Then again fast path, because session is already there. When it will do the flow lookup, it will found the session, so it will directly move toward the fast path and your forwarding stage. Now this server received this packet, and after that, because you know guys, this server is hosting the services on TCP 443. So what is the next packet which is initiated by the PC1? What is the first packet now? Like what is the packet number 4th? One person get like HTTP get, HTTP get. There is a one person called HTTPS get. And I got the correct answer from Kalpesh. That's true, Kalpesh. In once till here, what happened till here, till this particular time, till here, your TCP three-way handshake has been completed. TCP three-way handshake is completed. Now your SSL handshake will start, because you know this this server is hosting the service on HTTPS 443 used by the HTTPS, right? So now they will start the SSL handshake from here. In SSL handshake, what is the first packet? First packet is a client hello. So this is the packet number 4th, which is client hello. Now when this firewall receive this client hello, how this firewall going to do the processing? Let me put the client hello processing here. Ingress stage. Then your fellow lookup. Then your fast path. And after that, now guys, it will not go into the forwarding state. It will go on app ID. Then it will go for the content identification. And after that, it will go towards the forwarding stage. That's how the client hello has been processed by the firewall. Now guys, tell me one thing. Why firewall is not sending TCP SYN, TCP SYN plus ACK and TCP ACK packet towards the app engine and content engine? What was the reason? Are you guys able? Are you guys know what is the reason here? And I got the correct answer from Rahul. Yes, Rahul. Because you know, guys, TCP SYN plus ACK and ACK, these packets they don't have any type of layer 7 content. Because if they don't have any type of layer 7 in content, or they don't have any data at layer 7, then there is no sense to forward these particular packet SYN plus ACK and ACK towards the app ID and content ID. Okay, that was the reason, and you have to remember that reason. Because in interview maybe they will ask, you have configured the application based policies, but your firewall is not blocking that application right away. TCP three-way handshake is happening. Now you know the reason why like TCP three-way handshake is happening. Because SYN plus ACK and ACK, they don't have any layer 7 content, and by looking into these three packets, my Palo Alto firewall is not able to identify the actual application. Your actual application he will identify when client hello you will receive, either you will receive the next packet from the other end. Okay, cool. So guys, generally when Palo Alto receive these packet, it will start processing like that. Okay, now let me move further. Let me just explain you the other part of it. So what used to happen, we have a client which is an initiator, and we have a server. And when this client will start communication with this server, it will create a client to server flow. And if my firewall allow the client to server, means it will allow this traffic, then whatever reply will come, this reply will automatically allow by the firewall. Why it is allowing this particular reply packet? Are you guys able to answer this thing? Because stateful inspection, and your security policy is a part of silo path, right? And now it is not sending the packet into silo path, it is directly sending the packet towards the fast path. It is bypassing the silo path, right? So that is the reason it will allow that return packet right away. Okay, now, so generally what used to happen, if you will see, when firewall receive a packet, it will put this packet into the ingress stage, and after ingress stage we have a flow lookup. Then we have a silo path, then we have a fast path, then we have a application identification, then we have a content inspection, and after that we have a egress processing or forwarding stage. Egress stage or forwarding stage, both are same. And in your ingress stage, what used to happen generally, it will receive a packet on the interface, it will detect and drop the packet if there is any header errors, detect and block the pre-session or packet based. So let's suppose if someone trying to launch any type of DDoS attack, and if that IP address is a part of DDoS block table, it will basically block that particular packet as well. So what I will do, these are the things it will basically check into the ingress stage generally. Then we have a silo path. In silo path, what? It will basically do the routing lookup. It will check the net policies. It will check your security policies. It will check your DOS policies, all these type of things. In fast path, it will do the net translation and decryption. In AppID, it will try to do the application identification. In content, it will try to scan the layer 7 information if there is any type of virus or malware available in the layer 7 payload. And in forwarding, it will basically try to forward the packet. It will apply the quality of service and all these things. Now let me just go here. Let me just explain you the same thing in detail. And guys, I will just take a reference of two diagrams. Generally, I will just refer this diagram. This is the guy latest packet flow according to the latest operating system of your Palo Alto Firewall. And just tell me guys, are you able to see this information clearly? Increase the size little bit more. 78. This is the only size I can able to set here. Cool. Okay. Now let's try to understand this particular things now. So guys, these stages you can remember because we have discussed multiple times. So what used to happen generally when we receive a packet? So that generally that packet is always received by the Palo Alto Firewall on the interfaces, Ethernet 1x1, Ethernet 1x2, Ethernet 1x3, all these interfaces. Let me be clear, guys. If you will receive any packet on management interface, this packet will not process by the Palo Alto Firewall according to the packet flow. Okay, because you know this particular traffic coming for your firewall into your management interface. Management communication is always separate. This packet flow is applied for your data interfaces. Just remember. So when we receive a packet, so let's suppose there is a one PC and your inside network PC1 having this IP address 10.1.1.70. He has initiated that packet and that packet received by the Palo Alto Firewall on Ethernet 1x2 interface, and this interface is a part of inside zone. And this is your firewall. So what used to happen when this particular packet received by the firewall, what it will do? It will extract the layer 2 information, which means your source MAC, destination MAC. It will extract your layer 3 information, which is your source IP, destination IP. It will extract your layer 4 information, which is your source port and destination port. And guys, because you know my firewall know I have received this packet on Ethernet 1x2 interface. Means it's know the ingress interface, because you know this is the interface where I am receiving the packet, so that interface become like a ingress interface, right? So my firewall know I have received the packet on ingress interface, and he will do the zone lookup. What is the zone associated with this ingress interface? And he will find out this zone is inside. He will get the zone detail here. Now what, he has a source MAC, he is a destination MAC, he is a source IP, destination IP, source port, destination port, and also he has a detail of source zone. Now, sometime what used to happen, if we have received the packet in fragmented, let's say we have received the fragmented packet. So what used to happen for the fragmented packet, they used to do the IP reassembly, means they will make the full packet and after that only it will start the packet processing. Okay. So that's how these are the things which it will perform on this particular box. If you will see this box, these are the things it will basically check in this particular box. Like packet ingress process, extract layer 2, layer 3, layer 4 information. Then do the, let's just look for the ingress interface, got the source zone, do the IP fragment reassembly if required, and after that it will move further towards the ingress process errors. Means now it will check the header errors, basically if there is any error in the header, because you know sometimes the headers they used to have some type of errors. Basically what are these errors? packets may be discarded in your ingress state due to the protocol violation. Protocol violation means, let's suppose there is a one hacker. He had just modified the header details in IP header and your TCP header and UDP header, right? We have some predefined fields, right? These fields, they have some limitation and other thing. Let's suppose if somebody has modified these particular fields, means if somebody did the protocol violation, such type of packets is dropped by the firewall right away. Firewall attack prevention features may discard the packet without configurable option because those packets would eventually be discarded by end of the host anyways. Means the meaning of this line is that, let's suppose in the firewall we have received first packet as a SYN plus egg. Can you expect the first packet SYN plus egg, guys? What is the first packet in TCP 3-way handshake? SYN. If you have received the directly SYN plus egg packet, firewall will basically, what firewall used to do, it will basically prevent that particular packet. And after that, guys, what they will start the, what I have told you the extraction. What they used to do, the packet parsing. They will start doing the packet parsing at your layer 2, at layer 3 and layer 4 information is extracted, and ingress interface and zone lookup it will perform. Now let's try to understand what it will use to do in your layer 2 parsing. In your layer 2 parsing, it will basically extract, or it will start looking your layer 2 frame or your Ethernet header, and PANOS extract the source MAC and destination MAC from that header. Packet parsing start with layer 2, and guys, always when you Palo Alto start the packet processing, it will start from the layer 2 header. Then it will try to get the ingress port. If we are just receiving the packet with some VLAN tagging like 802.1q tag, let's suppose we have deployed firewall in layer 2 mode, right? In layer 2 mode, we can able to configure the VLAN other things on your firewall, right? So it will check the VLAN tag as well to get the actual VLAN details. Destination MAC address are used as a key to look up the ingress logical interface in case of layer 2 deployment, guys. If interface is not found, the packet is discarded and the hardware interface counter receive error, and the global counter flow receive.1q tag error will be incremented. And guys, how you will able to see these particular errors? If you will go into the firewall and you have to run this command, so counter global, this is the command, and here you will get all these type of error details. Like these type of errors counter will be increased during that time. Okay. Now, Mubarak, you can please write your question in a book. I will basically cover that part later. Okay, let me just focus on the packet flow because it's a big topic. If I will deviate from the topic, then maybe you guys not get 100%. Okay. And I like to explain you that packet processing 100%. So you have the entire idea. Okay. Now they will start the layer 3 parsing. In layer 3 parsing board, my PANOS, it will take the IP header, it will start parsing, and it will extract source IP and destination IP and IPv4 header. Let's suppose, because you know this layer 3 header, it can be a IPv4 and it can be a IPv6, right? Depending on the IP version. So let's suppose we are just using IPv4. So what a packet can be discarded for any of the reason. These are the header errors. Basically, it will check at your IP header. It will check mismatch of ether type and IP versions. So guys, when we will look your Ethernet frame, by looking into this Ethernet frame, we will get to know what is the layer 3 version we are using. Like we are using IPv4 or we are using IPv6, right? That information we will get from the frame or not. Generally, in Ethernet frame, we have a field called ether type. That particular field let us know the next layer version, like IP version. We have to use IP4, IP6. Let's suppose in Ethernet type, it is just telling the version is IPv6, but when my firewall did the parsing, he will found it's IPv4. It's a mismatch, right? So that type of packet is dropped by the firewall right away. So this is the first this is a first error which may occur in your layer 3 header. Truncated IP header. Truncated IP header means, guys, what is the size of IPv header? What is the minimum and maximum size of IPv4 header? Minimum is 20 byte and maximum is 60 byte. Let's suppose, and guys, these particular IP header has a predefined fields, right? It has a source IP field, destination IP field, right? It has a IP version field, fragmentation field, all of them. Let's suppose somebody has modified these particular fields, which is a problem, right? So if truncated means if some information has been removed from the actual IP header, these type of packet is dropped by the firewall right away. And guys, if your firewall dropping these packets, you will not able to see these these particular drops into this monitor or logs. No, you will not able to do that. You will not able to see these things in the logs. Okay, because logs comes when your packet is dropped by the security policies and other things. Okay, let's suppose we have received a packet with IP protocol number 0. If we are receiving these type of packets, what my firewall used to do, it will block the packet, right? It will drop that particular packet right away. Let's suppose I'm receiving a packet with TTL 0. Time to live value is 0 on the packet. These type of packet also firewall will drop right away. If on your packet, if source IP address equals to destination IP address, means source is same and destination is also same. In that case, firewall consider this as a land attack, and these type of packet is also dropped by the firewall right away. Then ping of death. Martian IP address. All these type of packets has been dropped by the firewall right away in your layer, in your IPv4 header. Then we have a IPv6 header, like mismatch ether type, truncated IPv6 header and truncated IP packet. These type of packet is dropped by the Palo Alto Firewall in case of IPv6. Jumbogram extension and truncated extension header, these packets is also dropped by the Palo Alto Firewall with regards to IPv6. And after that, it will do the layer 4 parsing or packet parsing. It will start at layer 4. In layer 4 generally, we have a TCP, we have a UDP, we have a ESP, we have a GRE, we have ICMP headers. And these are the main headers which generally you will see in the production environment at layer 4. In case of TCP, packet is discarded due to these reasons, like TCP header is truncated or modified. These type packet is dropped by the firewall right away. Data offset field is less than 5. In your TCP header, there is a data offset field, guys. And if that field is less than 5, what firewall will drop that particular packet as well. If, because you know in TCP we have a checksum, right? If there is a checksum error, it will basically drop that particular packet as well. If the port number is 0, it will drop that particular packet as well. If invalid combination of TCP flags, invalid combination means, can you able to see SYN plus FIN flag together? Can you able to see SYN and FIN flag together on a packet? No, that's not possible, right? So like if you have an invalid combination of TCP flags, it will drop these particular packets as well. And after that, it will start the UDP packet is discarded due to these reasons. UDP header truncated, UDP payload truncated, UDP buffer length less than the UDP length field, or checksum error. If they have these type of errors, they will basically drop all these packets. And guys, if your packet is dropping at the ingress stage, you will not able to see on the logs. That is correct, Mubarak. You will not get on the logs. There are the special commands you have to run to see these things. IP fragment reassembly if required. What it will do? If we have received the fragmented packet, what? IP fragment will be passed, reassembled by the defragmented process. So in your Palo Alto or in your PANOS, we have one process called defragmentation process. That process first do the IP reassembly, then fed back to the parser, and parsing will continue with the actual layer 3 IP header. A fragment may be discarded due to teardrop attack or overlapping fragments. Overlapping fragments means whatever fragments we have received. Let's suppose there are overlap, means some part of this fragment is available here and some part of that fragment is also available on the next one. This is the overlapping one. So this type of data is considered as a teardrop attack, and Palo Alto Firewall going to drop that packet right away or discard that packet. If one of the fragment are missing, all the fragment will be dropped since packet cannot be reconstructed. Means let's suppose after the fragmentation, that packet is fragmented into 3 fragments, and when firewall receive, only here receive 3. These type of packet is also, these fragments is dropped by the firewall right away. Then ingress processing error. All the above thing comes under the ingress processing error only, guys. And now if you will go here, let me show you the parsing as well, how they used to do the parsing. So guys, now just put your full attention here. You can see packet received at the ingress stage. So guys, these are the actual logs which, like, we have to run some advanced debug commands on the Palo Alto Firewall to see all these processing. And if your packet is dropped by the Palo Alto Firewall at ingress stage and all, this is the command which we generally use for the troubleshooting purpose. So what used to happen when we have received a packet, and as soon as we will receive that packet, it will go into the ingress stage processing. And in this, you can see we have, this is the length of packet, port number. So guys, your every interface like Ethernet 1x1, Ethernet 1x2, they have some port ID. And your Cisco devices also, you will get this port ID. Like, so let's suppose Ethernet 1x1 has port ID 16, then it has a 17 like that. Port 17, interface 17, virtual system 1. And after that, my Palo Alto Firewall has allocated the work queue index. This is the work queue index value. And now it has just start decoding the packet. Means it will start the extracting the information. And as I have told you, it will start at layer 2. This is the source MAC. This is the destination MAC. And this is the ether type. Then it will start layer 3 IPv header processing, source IP, destination IP, layer 3 protocol number, IPv4 version is 5, IPv4 header length, toss field length is 52, ID, fragmentation, offset, TTL value, checksum value, all of them. This is your IPv header. And after that, it has a TCP. This is your source port, destination port. And after that, we have a sequence number. This is the sequence number, acknowledgement number 0, because in TCP SYN, we just have a sequence number. We only have a sequence number, and acknowledgement number is always 0. Result field offset is 8. Windows size, checksum value. These are the flags. And generally right now on the very first packet, send flag is set. Urgent data. And this is the 14 data length. And they have some TCP optional fields as well. And once, guys, this particular processing has been completed, you can see now firewall is doing the flow lookup. It is doing the flow lookup, right? Now let me, because now let me just move here. Let me just go into this one. So guys, now ingress error. And after that, it will check for IPsec and SSL VPN. So guys, this particular, this particular document released by the Palo Alto Firewall in 2010. It's a very, very old document, okay? And the latest packet flow is happening on the firewall according to this one. Ingress process error. If there is any error on the packet, it will discard it. If there is no error in the packet, now it will forward this packet towards the DOS block table. Now it will basically check the DOS block table on the firewall. What is this DOS block table? Let's suppose somebody has launched any type of attack in your environment, like they have just launched the DDoS attack or IP spoofing attack, right? These type of attacks, if my firewall sees there is a attack is happening, what it will basically block these IP address and it will put these blocked IP address into the DOS block table. And if this IP address is a part of DOS block table, yes, then it will discard. If no, then it will forward this packet here. It will check firewall inspection applicable. If yes, then it will check for IPsec, SHS, SSL, VPN, GRE. If we are receiving the packet from these protocols like IPsec, which is ESP packets, SHS secure socket layer packet, like SHS secure cell, then SSL, which is your SSL VPN related packet, secure socket layer packet, or GRE packet, because your ESP, SSH, SSL, and GRE. What they used to do, these particular protocol, they used to hide the actual information, right? Actual header is, they generally used to hide the actual header. So what they used to do for these packets, if we are receiving these packet, yes, then firewall basically for IPsec ESP packet, what it will do, it will basically, in case of ESP packet, it will first check the hash. If hash is matched, it will allow the packet. If there is a mismatch with the hash, it will drop the packet right away. Then after the hashing means hash check means it will validate the integrity of the packet. And when I will discuss the VPN, that time this thing will be clear. Okay. Then after it will decrypted the packet and it will do the decapsulation. And once it will do all these things, they will get the actual IP header. Now this actual IP header, it will send again towards the ingress processing. If we are receiving the SSL VPN packet, what they will check the hash, they will do the decryption, and they will send this packet towards the ingress stage check again. For the GRE, they will do the hash check, they do decapsulation, and they will send that packet towards the ingress check. Now guys, let's see how this particular DOS block table looks like. So if I'll go here, if I run this command, debug data plane, show DOS block table, and you will see right now I don't have any IP on the block list. So what I can do, let me just launch one simple attack from my Kali Linux machine, and we will see how this particular firewall is maintaining the DOS block table. Because this is a something new endpoint. So I will just launch the using the nmap utility. I'm just launching the IP spoofing attack. Okay, and all the configuration already there. And when I will show you the DOS, like your DOS protection and your zone protection lecture, that time you will get to know all of them. Okay, but here my intention just to show you the content of the DOS block table. And right now you can see it has just created the DOS block table, and this is the IP address because I'm launching the attack from that IP address. So guys, what it will validate this particular table here. If you think this is a legitimate traffic, you can also able to clear the things. If you will run this command reset DOS, you can able to reset that particular table as well. And this will not impact anything. This is just a normal show command. Okay. It will not impact any type of CPU, nothing like that. It's just a normal show command. Cool. So guys, this part is, I have proved this part. It will check this particular table. We have seen this table as well, right? Because you know why I'm trying to explain this part again and again, because you know this information is not there into this particular packet flow. That is the main intention here. Okay, just remember. And after that, let me just stop the attack, because attack is still going on from this machine. Now guys, what it will do, if you remember from here, because we have initiated the traffic, we have initiated this traffic from this source. Or let me just go here. I will basically, I'm using multiple steps here. So guys, because you know I am initiating the traffic from this source 10.1.1.70. I'm sending the packet towards this server. So guys, just tell me one thing. What is the packet format looks like here? 10.1.1.70. This is the source IP. Then we have a 151.7.1 destination IP. Then we have a source port 1025 hypothetical and the destination port 443. And guys, also tell me one thing. When this particular packet reaches to this firewall, so what this firewall will do, it will extract your layer 3 information, right? Means your source IP address is extracted. Your destination IP is also extracted. Then your source port is extracted. Your destination port is extracted. And guys, in ingress stage processing, my firewall did the ingress zone lookup. He has the details of your source zone or not. Here we have a detail of source zone which is inside. And we know the layer 3 protocol number, right? For TCP, which is 6. And if you will see, these are the 6 tuple of my session table or not? These are the 6 tuple of my session table. So what my firewall will do now, it will basically run the MD5 hash on that. It will get the flow key here. It will get some value here. It will get the flow key. Now using this flow key, what it will do, it will do the perform the lookup into the session table. Guys, because you know, is there any session for this particular first packet? Is this particular, there is any session for this particular session? No, it's just a first packet, right? So guys, what it will do now, my firewall, it will use this flow lookup and it will perform the lookup into the session table. In session table, that particular table is stored actually into the MongoDB database. It will do the lookup into this database, and it will generally, it will not found any session, right? Now you can see here, you can see it is not able to found any session. It did the flow lookup. You can see these are, this is the flow key it has used. You will see this type of number. You can see, is there any type of session? No. There is no active session. The one person has asked how it will do the lookup on database. It will basically run the query, man. Okay. It's not a database class. Okay. It will use to do the lookup in the database. Like it will use maybe SQL query, whatever. Don't care about it. Okay. So right now there is no active session. So you can see no active session flow found in queue to create a session. It is sending this packet towards in queue to create a session. And you can see now packet receive at the slow path stage. So if there is no session, packet will be always go into your slow path, which is or your connection setup state here. Firewall session lookup, session match. If yes, then fast path. If no, then slow path. Firewall session setup or slow path stage. Now in this stage, what is going to happen? So I will not refer this particular diagram here, guys. I will refer the latest one. Okay. And guys, remember one thing. Firewall failure lookup match by using the 6 tuple extracted at ingress stage. And guys, all these 6 tuple it has already extracted. Okay. This time there is no flow. No flow means it will go into the session setup state, which is slow path. Okay. Now in this slow path, before going to this slow path part, guys, let me just cover one more thing, because you know this thing definitely you will get in the interview. So guys, generally what is flow key? Flow key is a hash of 6 tuples. We have a 2 flows, client to server, 1 flow key. We have a server to client, 1 flow key. And guys, just tell me one thing. It's just a general question. For TCP, in TCP, we have a field called source port and we have a field called destination port, right? And they are using this source port and destination port field, like they will include into your 6 tuple for creating the keys, for creating the flow key, right? These are the part of your 6 tuple information. For UDP also, in UDP header, we have a source port field and destination port field, right or not? But about the ICMP, in your ICMP header, do you see any type of source port or destination port field? I hope guys, you know the ICMP header. Do you see any type of source port and destination port field for ESP header? Do you see any type of source port and destination port field for GRE packets? Now, how my firewall is going to handle, how it will basically create a 6 tuple information for ICMP, for ESP, for GRE packets? Because in any your interview, they are going to ask this thing. I got answer from Maninder on the basis of IP address. Guys, try to write the some legitimate information. Okay. Do not guess. Guessing will not work here. Okay. If you know that is good, you can write at least like 20-30% correct answer. Okay. Now let me just go here. ICMP header diagram. Oh, it's very bad. It's not coming properly. So guys, in your ICMP header, if you will see, this is not the correct one. ICMP header, where is that one? Type code, checksum. This is the one. Let me open into the new link. This is also having the correct information. Okay, so guys, if you will see this diagram, this is the header of your ICMP packet. So guys, in your ICMP packet, what it used to have, it has a two field called identifier and sequence number. So what used to happen, it will consider this identifier as a source port and sequence number as a destination port. It will use these identification identification number and your sequence number, or identifier or sequence number, these two things from the ICMP header. Your firewall use identifier as a source port and a sequence number as a destination port. Now guys, are you able to answer this thing if somebody asking? Yes, no on the chat? Because this question you will get, definitely you will get, because this is the question asked by the interviewer. TCP, UDP, everyone know, but ICE, they will just ask some tricky question. Okay, now let me just ESP header. Let me look for some good ESP header diagram. Okay, now in this ESP header, guys, how it used to do, generally for IPsec packet, who has maybe worked with the VPNs, they definitely know SPI numbers, SPI in, and they may also know SPI out, SPI inbound and SPI outbound, inbound and outbound, right? Service parameter index. And your ESP header has a this particular field called SPI field. So your Palo Alto firewall going to use this SPI number. It will use this SPI value as a source port and as a destination port. Just remember. So for IPsec ESP packets, how it will get the source details and destination port detail by looking into the SPI numbers. Now, let's look for the GRE header. In GRE packet, basically what we have there is a one field called caller ID. And they are going to use that particular caller ID field for GRE header. I'm not able to get the proper details. In case of GRE, what they will consider the caller ID or call ID as a source and destination port field, guys. Just remember. Okay. You have to just remember these parts. Now, and also one more thing, just remember, guys, when Palo Alto Firewall create a session, every session have a lifetime. Like it, every session has a stage. We have a init, opening, active, discard, closing, closed, free. And where, guys, in your Palo Alto Firewall, you can able to see init, active, and discard. Only these three stages is available, or you can only able to see these stages. Remaining stages are the transient state. Transient state means they are there for the frequent of the seconds. So you will not able to see these particular stages, but most of the time you will see discard, active, and init. Init means initialization stage. Now, let me just go back here. Let's try to move here into your slow path or session setup stage. Now in session setup stage, if you will see, the very first thing which is checked by the firewall is your zone protection profile. Means if we have configured any type of protection into the zone, it will check the zone protection profile. And it will also check the TCP state check. These are the two checks it is going to perform here. Zone protection profile and TCP state check. What is the state of TCP session? And what for zone protection profile? It generally use two things: randomly drop, or it will use the SYN cookies. These are the two methods it will use. And this zone protection profile protects us from the TCP flood attack, UDP flood attack, ICMP flood attack. If someone is trying to launch any type of IP spoofing attack, so such type of attack prevention you will get with the help of zone protection profile, or IP spoofing attack. That protection you will get from the zone protection profile. It will check for the anomaly or error on your packet. And after that, it will move further for the next check. And here it is going to check the IP to user, IP user, or user to group mapping. Means it will check for the IP, use IP to group mapping, or user to IP mapping, this one. So user, IP user mapping, all. It will check this particular mapping. Whatever the user to IP cache you are having, it will basically check that particular cache. Okay, just remember. No. So guys, your user to IP cache, it will check in your silo part to get the actual IP, actual user who is basically holding the IP address. Why it is basically doing that lookup here? So it can enforce the user based security policy, because you can able to configure the user based security policies. Mean you can block some traffic for some user on the basis of username. Now you don't need to block everything using the IP address. You can block using the username, because in production environment, everyone needs to log in with his ID on the workstations. Now they can able to restrict, like for HR people, you will give the access of appropriate websites. You like for your IT people, you can give the appropriate access. For sales people, you can give the appropriate access, right? These type of things you can able to control with the, and if you have these type of policies, that user to IP enforcement happens here. And this enforcement is only happened if you have enabled the user identification on your security zone, or on your ingress on that particular zone. If that thing is enabled, then only it will do the user to IP mapping. Okay. And how it is getting this user to IP mapping? We have to configure the user ID. We have to create a user identification configuration on the Palo, and I will cover that part in your later classes. Okay. But as I have shown you, it used to create this type of mapping, as we can see here. And let me just show you one more thing. If let's suppose I have this PC, because this PC is a part of my domain. If I will log in into this PC, let's suppose the username I will use here, Hemu. Password is admin at 123. And I will use my company details here. And if you will see here, this time binding will be there for Hemu. This is the IP address of Hemu, and this is the username of Hemu. And how will I get this detail? I get this detail via AD server. So it will check for this particular mapping. Now, after that, it will move further. Now it will basically check the very next thing, which is application cache information. Because in your silo path, firewall try to do the lookup into the app ID cache. Because why it will do the lookup into the app ID cache? Because your firewall, it used to maintain the cache detail for applications. Why it is maintaining that detail? Because if we will get the detail of application from here, then we don't need to send that packet to the app ID engine. If we know the application, then we never send that packet again to app engine. So to offload some load, or to enhance the performance of the firewall, they have added this particular app ID concept here. And let me just show you one thing. I'll go here. So DOS block table, there are some commands I have written. Tunnel decapsulation they used to do. For IPsec, they do the hash validation, decryption, decapsulation. And I'll share this particular diagram so you don't need to worry about it. Then flow lookup. Then silo path, zone protection profile check, SYN cookies. All these things we will discuss, so you will get the idea, like TCP state check, TCP state for inspection enabled, non-SYN packet for new session will be discarded right away, right? All these things. And we can also able to control that part. We can able to basically disable that behavior. What is the meaning of this TCP state check? I think I have not explained you the much thing on this. TCP state check means, let me just show you one thing. Let's suppose I have this diagram. I have this PC here. We have one router here. We have firewall here. And after that, we have one more router here. This is R1, then this is R2, and we have one server here. And somehow this R1 and R2 also have a connectivity like that. So what happening when this PC is sending any traffic? This traffic is going on R1, then it is going towards the firewall, then it is going towards this R2, then server. And after that, what is happening? Or let me just explain you in this way. PC initiated first packet, and first packet is always a TCP SYN packet. And now TCP SYN took this particular path. It reached till R2, and after it will reach till this server. Now when server give the reply, in reply he will send SYN plus ACK. Now my firewall is receiving here what? SYN plus ACK. And instead of SYN, he is receiving SYN plus ACK. So this packet by default it will drop. But you can able to disable that behavior. If you will run this command, it will basically start accepting these type packets as well. And this setting you needed, or these type of packet, you will see if there is a asymmetric routing in the environment. If we have a asymmetric routing environment, in that case only these type of packets you will get. Like, because if you have a two paths, in one path firewall bypassing, firewall is bypassed, in second path firewall is in inline. Okay. So TCP state check means it will just check for that, and you can able to disable these things. We have the commands. You can run this command. This command will disable for temporary. You can want permanent. You can do with that. Okay. Then it will check the IP or user cache information. Then your application cache, and how it will do the application check. So if you will run this command debug data plane, so running application cache, this is the command which will show you what is the cache information we are having here. If I run this console application, not like that, so running, and when we will add so running means we are looking the details in your data plane application cache. Right now you can see I have a list of these applications, and because these are not a legitimate ones, so what I will do, if I'll go here on my inside PC, if I'll open this browser, let me just try to access the facebook.com, and you will able to see the details. Let me try to open Netflix as well. Now I have one mapping only, but it will, I'm not sure why it is not able to communicate over the internet. I know why it is not able to do that, because on my firewall looks like I have the wrong routing. Because I was using that because right now I'm on my native, so I have basically I'm getting some different IP address on my router. That is the main reason, because my default gateway was wrong here. I have to basically change this with 192.168.1.1. Now things will work. Let's wait here. So guys, are you getting the things what I'm trying to explain? Because packet flow, if you will know that packet flow in detail, you can able to troubleshoot the issues actually. At least you will able to understand where my packet is going and what's happening how when my pan OS is doing the packet processing. Let's wait for this commit to complete. Meanwhile, so guys, these are the command. Debug data plane, reset app ID cache, but it will delete the app ID cache. So running application cache, it will basically show you the application cache information. Set application cache, no, it will basically disable the app ID cache feature on your firewall. This will enable. So running application cache, this will show you what is the setting right now you will be having. Because guys, in your this diagram, we don't have anything with regards to app ID cache, no zone protection related info here. Why we are not having that information? Because it has a little bit, because this is a little bit old diagram. Okay, user cache is information is also not there. This time if I'll go here, if I will open Facebook, if I'll open Netflix, ping is working. I think Netflix is blocked. What about the Facebook? It is also blocked. For user Hemu, right? It is blocked for me. I was doing some tests. That is the reason. Now you can see I have the details, right? This IP address belongs to Facebook, and this IP address belongs to Netflix. Okay, just remember. And here you can see it will basically put the destination IP address, destination port detail, and your layer 3 protocol number. This is your layer 3 protocol number. These are the three values. Generally, it will store into your app ID cache. Look, let's go back here. So when it will do the lookup for app ID cache, it will do the lookup on the basis of destination IP, destination port, and protocol. Now,